All right. Hello, guys. This is obviously your teacher, Mr. O. So I'm going to make this video for you guys because I'm out of town and I need to go over this with you. So I need you guys to buckle up. Okay. I don't want anyone to be on their laptops or their phones. So whoever's the sub, hopefully they can police that. I'm going to put that in the notes just so you guys know. I need you to pay attention. Okay. So if you're watching this video, hopefully you did the warm up before this. That should be the goal. So what I'm going to do is I'm going to go over this lesson, and then afterwards your sub is also going to show you a short video. It's really important that you pay attention. Again, no laptops or phones out during that video either. This isn't going to take the full class, like the whole lesson plan, so you guys will have plenty of time to hang out, but I need you guys to stay on task for right now, so hopefully your sub is on top of that. But we're going to go over the homework. So if you guys got below 50 on the homework, come see me on Monday. I'll give you the packet for it, but it's important that I go over this with you guys right now. So this is going to be for parts 1 and 2 for chapter 2.4, slopes of parallel and perpendicular lines. And I'm just going to go through it. So let's go ahead and get started. So obviously our objectives here is to understand the relationship between slope of parallel and perpendicular lines and review all the homework. So we're going to start with the first part of the homework, okay? And we're going to start with question number 5. If you guys have the packets or, you have your homework open to that question, I suppose. This was part 1, question 5. So we're looking at the graph to the right. We want to know, are lines L1 and L2 parallel to each other? So the key here is when we're doing this, if lines are parallel, it means they have the same exact slope. If they don't have the same slope, they're not parallel. So that means we're going to have to find the slope of both lines. I think that's what I have here in this next slide. In order to do this, we need to find out, okay, they have to have the same slope. So we need to find the slope of each of these. So how do we do that? Well, I have both points, right? I have slope for L2, okay, it's the line here on top, and it's at points 0, 3 and 8, 1. So that's at, what I'm going to do is, again, how do you know what x1 and y1 is and x2 and y2? You're going to go from left to right. Whatever point you hit first, that is your x1 and y1. The second point is going to be your x2 and y2. All right, so the formula for slope is y2 minus y1. So I'm going to take my y2 that I've labeled, which is 1, and subtract it from my y1, which is 3, okay? 1 minus 3 is negative 2. Same thing at the bottom, x2 minus x1. My x2 is 8, and my x1 is 0, okay? You're not subtracting your x1 and your y1 from each other, okay? You got to plug it into the formula. So that gives you 8 minus 0, excuse me. So, like we just said, 1 minus 3 is negative 2, and then 8 minus 0 is 8. So that is your slope for the first line. Now we need to do the same thing, but for line 1, right? The bottom line here. Again, I have my 2 points, negative 8, 1. Going from left to right here, my first set of points, that's my x1 and y1. 0, negative 3, those are my second set of points. So that's my x2 and my y2. All right, so we just have to use the slope formula again. y2 minus y1, my y2 is negative 3. My y1 is negative 1, so that's negative 3 minus negative 1. Whenever you subtract a negative number, it becomes a positive. So really, this is negative 3 plus 1, so that's negative 2. Can do the bottom now, x2 minus x1. My x2 is 0. My x1 is negative 8. So that's 0 minus negative 8. When you subtract a negative number, it becomes a positive. So really what I'm saying is 0 plus 8. So again, we can just go ahead and calculate that. Ends up being a negative 2 over 8. Now, as you can probably tell, now you can probably tell these have the same lines, right? Or they have the same slope. If they have the same slope, that means they're parallel to each other. So looking at the answer choices here, yes, it's going to be A. Lines 1 and 2 are parallel because they have the same slope. All right, so now we're going to go, staying in homework part 1, we're going to go to question 6. This is very familiar to what you've been doing on your warm-ups, but we're going to go ahead and go through it now. So we have a line K that passes through points negative 5, negative 13, and 1, 17. Then we have a second line, line H. That passes through negative 3, negative 23, and 3, 7. We want to know if these lines are parallel to each other. So what we're going to do here is we're going to find the slope of each line. So I have my 2 points, negative 5, 13, that's my x1 and y1, and then 117, that's my x2 and y2. All I have to do is plug it into the formula, y2 minus y1, 17 minus negative 13, and at the bottom is my x2 minus x1, that's 1 minus negative 5. So 7 minus negative 13, again, subtracting a negative number, so really what I'm saying is 17 plus 13. That gives me 30. And then I have 1 minus negative 5. When I subtract a negative number, it becomes positive, so that's a 6. Now, what I have to do here, and something that you just did on your warm-up before you saw this video, talked about reducing fractions, right? Both of these numbers are divisible by 6, so I can divide both the top and bottom by 6. 6 goes into 35 times. 6 goes into itself, obviously, just one time. Now we can jump to the other side. That was for line K. Oh, this is for line H. This should not say L1. I'll change it right now for line H. Okay, so negative 3 comma negative 23, that's my x1 and y1, and then 3 comma 7, that's my x2 and my y2. So then all I have to do is take the slope formula, y2 minus y1, x2 over, or x2 minus x1, and solve. So my y2 is 7 minus negative 23, and then 3 minus negative 3. Whenever you subtract a negative number, it becomes positive. So really this is 7 plus 23, that's 30. 3 minus negative 3, subtracting a negative number. So really this is 3 plus 3, so that's 6. So then I have 30 over 6. Pretty much, well, not pretty much, it is the same fraction, reducing it. Both of them are divisible by 6. So 30 divided by 6 is 5, 6 divided by 6 is 1. So here are both of my slopes simplified, meaning if I go to the next thing, I need to compare the slopes. Are they parallel? Yes, because they have the same slope, they are parallel to each other. All right, so that is, yes, the lines have the same slope. That's why they're parallel. Okay, so now we're getting into a little bit of the harder part. This is homework part 2. So it says on the graph to the right, I'm going to blow this up on the next slide, don't worry. It wants to know if these two are perpendicular to each other. Well, let's go ahead and take a look. So if they're perpendicular, right, the key here is in order for the two lines to be perpendicular, the product of the two slopes must be -1. That means I need to take the two slopes and multiply them together. If the answer is -1, yes, they are perpendicular. If the answer is not -1, they are not perpendicular, okay? You need to multiply the two slopes together and see if the answer is -1. That's how you find out if it's perpendicular. So what I have to do is I have to find the slope of each of these lines. Let's start with L1, right? So L1 has points at -2, 0, and 7, comma -6. I need to find the slope. So all I'm going to do is take my slope formula and I'm going to plug it in. My y2 is -6 minus 0, my y1, or 0 here. Okay, and then my x2 minus x1, that's 7 minus -2. -6 minus 0, it's obviously the same thing. That's -6. 7 minus -2, I'm subtracting a negative number, so it becomes positive. So really what I'm saying is 7 plus 2. So that gives me 9. So it's -6 over 9. Now I can reduce this fraction. They're both divisible by 3. So when I do that, 6 divided by 3 is -2. 9 divided by 3 is obviously just 3. So my slope simplified here is -2 over 3. Now I can go to the next one. I need to find the slope of also the next line. My next line has points at 3, comma -8 and 6, comma 4. So all I have to do is plug it into the slope formula. y2 minus y1. My y2 is 4. My y1 is -8. My x2 minus x1, so my x2 is 6, and my x1 is 3. Just taking my labeled points and I'm plugging it into the formula. So 4 minus -8, I'm subtracting a negative number. So really what I'm saying is 4 plus 8. That gives me 12. And then I have 6 minus 3. Okay, 6 minus 3 is 3. Nothing too crazy there. So again, this fraction can be reduced down. Both of these numbers are obviously divisible by 3. So that's going to give me 4, right? 12 divided by 3, that is 4. And then 3 divided by itself is 1. Now all I have to do is take this number and multiply them together, right? I'm checking if they are perpendicular to each other. So I take the slopes of both of these lines. When you multiply fractions, you multiply across. So really it's 4 times -2, that's -8. Then I have 1 times 3, that's 3. All right. This number, -8 over 3, is not -1, obviously. Okay, so that's like 2 2/3. So these lines are not perpendicular to each other. That's the only way that you can check. All right, and that is going to jump us to the last question that you guys need to go over. So this is from part 2. This is question 3. So we want to know all this information. The first thing that you need to know is that the little upside down T means that it's asking if they're perpendicular. The two straight lines, that means parallel. So I want to know if M and N are parallel, P and Q are perpendicular, Q and N are perpendicular, and P and M perpendicular. The only way that we're going to be able to solve this is essentially we have to create some sort of like word bank or answer bank for our slope. So all we have to do is to solve this problem, we got to find the slope of each individual line. It's going to take us a little bit, but you should be familiar with the process of finding slope. So I'm going to take my first point, my second point. I've pointed them out here. You can see it. So again, going left to right, finding out what my x1, y1 is. So that's -2, 7. That's my x1 and y1. And on my second set of points, that is 3, 5. So all I have to do is take the slope formula, y2 minus y1 over x2 minus x1, and plug it in. My y2 is 5 minus my y1, which is 7. My x2 is 3 minus my x1, which is negative 2. 5 minus 7 is negative 2. 3 minus negative 2. Again, I'm subtracting a negative number, so really it's 3 plus 2, and that's 5. So the slope of m is negative 2 comma 5, or negative 2 over 5. All right, I can go to the next one. Here are my 2 points. This is the slope for line n. It's at negative 5, 0, and 0 comma negative 2. Here's my x1 and y1. My negative 5 comma 0 is my x1, y1. 0 comma negative 2 is my x2, y2, right? Going left to right to find out which point is which. My x1 and y1. All right, so now all we have to do is solve for the slope. So my y2 minus y1, that's negative 2 minus 0. And then I take my x2, 0, subtract it from my x1, which is negative 5. So that's negative 2 minus 0, that's negative 2. 0 minus negative 5, I'm subtracting a negative number, so really it's a positive. So really what I'm saying is 0 plus 5. And that gives me my slope, negative 2 over 5. Now I can just keep going. We can go to slope P. Okay, I have my 2 points. 6 comma 15, going from left to right. Here's my first point, 6 comma 15. And then I can keep going, 10 comma 5. That's my x2 and my y2. All I have to do is take those, plug it into the slope formula. y2 minus y1. My y2 is 5, okay, minus my y1, which is 15. Now I can do the same thing. x2, which is 10, minus x1, which is 6. So 5 minus 15 is negative 10. 10 minus 6 is 4. So all I have to do is reduce this fraction, right? You got to be careful. Both of them are divisible by 2. So 2, or negative 10 divided by 2 is negative 5. 4 divided by 2 is 2. So I have a slope here, negative 5 over 2. Now I can go over the last line. This one we have to get a little bit creative with, okay? So it only gives you 6 comma 15, but it doesn't give you, or should say it doesn't label on the graph here, another point to give you, right? It doesn't give you 2 coordinates. But we also learned in our warm-up, we can find easily identifiable points, right? Following this line, where does it hit the perfect corner of one of these grid squares? Well, I see it right here, and this grid square is right here at 8 comma 20. So really we can make our own second point. I think that's a typo in your book, to be completely honest with you, but still, we can solve the problem all the same. So I have my first point here at 615, that's my x1 and y1. Then I have my newly created point, 820, that's my x2 and y2. All I have to do now is take my points and plug it into the slope formula. y2 minus y1, that's 20 minus 15. x2 minus x1, that's 8 minus 6. And that's going to give me an answer of 5 over 2. All right, so now we just did the brunt of the work. All we have to do is check our answers now. So what I have here is a little bit of word bank for all the slopes. Now we can just kind of plug them in as we need them to. So A is asking, is P perpendicular to Q? The way that we check that, we multiply the 2 fractions together and we see, does the answer equal negative 1? Well, negative, when we multiply fractions, we multiply across. So negative 5 times 5, that's negative 25. 2 times 2, that's 4. Okay, that does not equal negative 1. That's like a pretty big number. It's like 6 and 1/4. So obviously that does not equal negative 1. So no, those 2 lines are not parallel to each other. Okay, no surprises there. All right, now we can go to B. B says, is Q perpendicular to N? So I take my, slope of Q, that's 5 over 2. I take the slope of N, I multiply them together, that's negative 2 over 5. Whenever we have fractions, we multiply across. So that's 5 times negative 2, which is negative 10. 2 times 5, of course, is just 10. So now we take that and we can reduce it. Well, negative 10 divided by 10 is obviously just negative 1. So yes, when I multiplied the 2 slopes together, the answer was negative 1, meaning those 2 lines are perpendicular to each other. Now I can keep going. C, is M parallel to N? All we have to do is take those 2 slopes. The slope of N is negative 2/5. The slope of N is negative 2/5. So yes, the 2 lines are parallel, right? If they have the same slope, that means they're parallel to each other. Okay, last one here. We want to know if D is perpendicular to M. Well, I had to take the slope of P, which is negative 5 over 2. I take the slope of N, which is negative 2 over 5. Whenever I have my fractions, I multiply across. Now I have to be careful here. Negative 5 times negative 2, when 2 negative numbers are multiplied together, they become a positive. So really it's a positive 10. 2 times 5 is also just a positive 10. So as I'm looking here, okay, obviously 1 is not negative 1. Even though it's both the number 1, 1 is negative, 1 is not, okay? It has to be a negative 1 for them to be perpendicular, not a positive 1. So those 2 lines are not perpendicular to each other. So this is just a kind of a final summary. A, no. B and C, yes. And D, no. Okay, so that is the lesson that I needed to teach you guys. So now would be the time for you guys to watch the video, for the next lesson. I'm going to try to put this video also on Canvas in case you need to watch it later. If this is something you guys like, you can also let me know. Maybe I can start recording the homework reviews. If this is a format you like, you'll have to tell me on Monday. So, yep, go ahead and get started on that video. The sub's going to go ahead and play that now, and then you guys can finish things off, get caught up with homework, whatever it may be for the rest of class.